Hi, I'm Bob Alsop with ShopSabre CNC. Around here they call me RouterBob. Welcome to the ShopSabre Make It series videos with RouterBob. Today we're going to be making a Les Paul guitar body. And I selected that because there's a lot of neat operations in it. And if you're part of the SabreNation community, you will have access to the files that we use to create this. Let's get started. The first thing I wanted to do was to find a drawing or a model of a Les Paul guitar body. And so that was the starting point, and I was able to download a pretty good model. There's a lot of them out there. So that was the place to start. And I selected this project because it's complicated. It's got backside machining. It's got a lot of special setup stuff. And I thought those are things that you could actually apply to other projects that you make on your CNC. Let's take a look at the model itself. This is what a Les Paul body looks like. A Les Paul guitar body actually has two parts. You can see by the different kinds of wood here, that's a cap, and we'll turn that off. And then we have a main body. And let's take a look at that, because one of the things that's so neat about this project is the complexity of the machine on both sides. So let's look at the back. All right, I probably want to fly cut this so that it's flat. What else do I have to do? There's a pocket that has to be cut here and one here, and there's some holes for location. And it looks like there's a round over all the way around this, and it's 1/8 of an inch, and it's consistent, so I can either treat it as a 3D surface or use a form tool. I think we'll try the form tool. We'll also cut this out, leave about 30 thousandths, and cut about halfway through so it stays connected to the main blank. When we cut this side, we have to cut this through, and we have to cut this all the way through, and we have to cut this groove. The rest of this machine can be done once the cap's on. There's one other operation I'm going to add, and that is I'm actually going to pocket a bunch of material out here because these guitars are really heavy if you don't. All right, let's put the cap back on. Now the cap is a 3D surface, so we cut that, and then these are 4 holes. Those are for switches. Same thing over here. Then we also cut the perimeter, and then we'll also cut these control cutouts all the way through. And there's one other thing. If you look at the bottom, this is an incline, so this is technically a 3D surface. There's one operation that we won't be able to do in this setup, and that's the horizontal boring. That'll have to be done a different way. But that's a Les Paul guitar body. Now let's look at this in much greater detail. Now that we've figured out the product, how do we make it? Well, first off, we're going to make it on a ShopSabre 23, which is a really, really nice machine. It's kind of an entry-level CNC router. The work envelope is actually 30 inches by 40 inches by 5 inches thick, so it'll all fit inside of there. The machine has a phenolic table. It has T-slots. It also has a vacuum. We're not going to use the vacuum. We will use the T-slots. The machine also has a 4th axis on the side, but we won't need that for this project. So that's what we're going to use. Now, how do you go from this model? Well, start thinking about what size piece of wood do you need to make this out of. That's probably the first place to look. So let's go back and look at the model, and let's talk about that. There's our body, and let's go ahead and look at it from ghosted so we can see inside. And we're not going to make the top to start with. We're going to make the bottom part. So that's the piece. So the first thing to do is we really have to figure out how big is the blank, all right? And what we can do is take a bounding box, and a bounding box is a rectangle that defines the minimum size that part will fit in. All right, well, you really don't want to just cut with a bounding box, because when you cut stuff out, you're going to have these corners, and they're going to be projectiles. So what we really want to start with is probably a blank that's oversized. And that way, when we cut the scrap pieces out, they're all held on a skeleton, and that makes it a lot easier. And you can kind of see how we've got that fit in there. And the materials is going to be extra thick to start with, because we're going to machine both sides of it. Now, sometimes what happens is you say, okay, this is what I'm going to use. But when you order your material and you get it in, it comes out slightly larger. In our case, our blanks were a little larger than what we specified. So this is what they actually came out. So that's actually what our blanks are going to be. And you know, that doesn't cause a problem at all. I'm going to be adjusting thickness anyway, and being a little bit too big doesn't matter. I'm just going to change the fly cut program a little bit, and we'll get into that a little bit more. Okay, now let's turn those off. So we'll turn the blank off. Now we're back down to our shape, and let's turn that off. Now, where do I get the geometry, okay? Well, if you notice this pocket right here, that's just a shape cut to a certain depth. That's what we call 2.5D machining. All right, so all I need is that shape, and I need to know how deep it is, and that's all it's going to take. So what I'm going to do from this model is I'm actually going to take some geometry off of it. And when you have an edge might be the intersection of this plane and that plane. The intersection is a line. So what I can do is I can take those lines and project them down to what's called a construction plane, which is a flat plane underneath, and output that as a Dxf drawing. So I can get all the details off that model I need into a Dxf drawing that I can actually bring into Vcard Pro and Toolpath, as long as I know the depths of the cut. So that's how we're going to approach this. Okay, here's an example of the Dxf drawing, and you can kind of see where the shapes came from. All right, now first off, this outside blank, let me show you what that represents. If we go back over here, okay, that piece is 15.5 by 20, so when I initially set this up, I decided that was the size of the blank that I wanted to use, so that's where that came from. So that gives me some space. When these corners get cut out, that keeps everything framed. Now you'll notice here there's two holes here, one in here and here. Those are for pins, and those enable us to actually flip the part over and get it lined up correctly. So those are pins. All right, now if you notice, I've got some geometry in different colors here. Okay, because think about this. Some of this geometry is on the front and some is on the back. Now if you notice the red geometry, those are operations that have to be done to start with, so it's the bottom side. So that has to be flipped. Therefore, that drawing actually has to be mirrored. All right, and then you see these other cutouts. These are actually done from the top. Now there is one other piece of geometry that I added, and that's this cutout. And what that's I'm actually gonna cut this out just to remove a lot of material. So basically, that's all I need to do this Les Paul guitar. Plus, I've got a couple other little things I'll have to have. I'll have to have the surface for the top of the guitar, and I'll have to have the surface for that pocket. We'll get into that later. So basically, where you start with is you start with the basic Dxf drawing like that. And everything gets lined up based on the perimeter of that cut. All right, now, let's start thinking a little bit about the machine itself and how we set this up on the machine. The drawing you see on the screen here is what we actually use for alignment so that we know where the part is in relation to the machine table. Now let me explain to you how that's done a little bit. First off, we're going to use a sacrificial board, or in our case we're going to call it a fixture board, that's attached to the machine top, and it's clamped down with the T-slots and the clamps, and it's oversized. And the material, in our case, is 3/4 inch MDF, and then it has a melamine surface, so that tape sticks really well to it. So somewhere on that board, we have to figure out where we're going to put the part, and that's what this drawing does. So basically, I locate where I want the center of the blank to be, and I make a note of that, and I say, okay, this is going to be the origin. I set that in the machine. It's the XY0, and then that's what this intersection is here, and that's determined right here. So basically, that's what determines where this machining is going to occur on the machine table. Now let's look at what other machining we're going to do in the setup phase. Well, for one thing, what you see here was the original blank size that I had calculated that I wanted. And once again, when I got the material blanks in, they were oversized. And so I just made that adjustment here. So the blanks are actually 16.5 by 21. Okay, these little holes here, these are pockets. And what they're for is, I machined some pockets in there so that it's easier to pry the boards up once they're taped down. And then this represents, these are the pins. So the actually pins after one size of machine, then the pins are inserted, and that's what aligns the top and the bottom. And then finally, here's what the actual outline looks. Let's look at simulation. And so here's the pockets, and here's one of the first outlines. And that outline actually shows you where to put the blank. As long as you have material outside of that, everything works. And then here's the outline of the body itself and the pins. So then we'll generate the G-code for that, and now we're ready to go out to the machine and actually set that up. And that shows us how we make the transition from the software to the machine itself. All right, you can see our fixture board on the machine. It's clamped in place with the T-slots. You can see the machining that we did, and those were the Toolpaths that were generated with Vcard Pro earlier. You also see the part locator pins, and I put those in there at this point just to make sure they fit okay. Now, The next thing was to apply double stick tape, and this is 3M 9579 double stick tape. That surface has been fly cut, and you really need a smooth surface for the tape to work well. Then it's just a matter of positioning the blank so that it's over all the machining, and then apply a little pressure to make the double stick tape stick to it. And now this part's actually ready for our first machining operations. Now we need to think about how we're actually going to toolpath this. Think about this, there's really three setups, because you have the bottom piece and it has machining on both sides, then a cap goes on top of that, and then it gets machined from the top. So there's really three distinct setups there. But before we get into that, I want to go back a little bit. If you notice on the last scene, I actually taped down a blank, and that's one surface of that blank was fly cut. Now the reason I did that is because for double stick tape to work well, it has to be a pretty smooth, flat surface. Sometimes we don't have a planer big enough for the blank. So in this case, what I actually did was I took a larger piece of plywood, screwed it onto the back in some scrap areas, clamped the plywood to the table, and then fly cut that. Let me show you how I actually created that toolpath. What you see on the screen actually represents our blank. So what I want to do is start out and create a toolpath to fly cut that. But I don't want to use a pocket or anything. I basically want to just draw the lines I need to cut that. So here's how I start. I'm going to start with a line, and we'll space it here, and I'll type in 21, and that should give me that line. Okay, so there's the first line. Okay, now the tool I'm using is an 1.5 inch braze tool. It's very inexpensive. I use them all the time. I even use them for fly cutting spoil boards for cabinets, but it's a really nice tool. So what I want to do now is I want to offset this about half that, so 3/4. So I go down here. We're going to offset 3/4, and let's just see what we get. Okay, that's fine. Now it looks like I've got some extra lines, so we'll just get rid of those. Get rid of those. All right, now, then the next step is to put a straight line here, down to here, and do the same thing down here. So we'll put a straight line from here, let's snap to the ends. Okay, so far so good. Now let's take the scissor tool and let's get rid of some things we don't need. It's that one. I'm going to delete every other one. Okay, that looks pretty good. We'll go down here to the bottom, do the same thing. What my goal is to create a single line that I can run a tool down the center of, and it creates a fly cut program. Okay, so that looks pretty good. Now let's take those and let's join to make sure they're joined. Yep, one open vector, and then we'll center it. So we'll just click that. We'll say center on the material. There we are. Now what I want to do up here is I actually want to add a line here. So let's do this. And I'm going to make that line about 0.75. What I want to happen is I basically want the cutter to come down here in space and then start cutting. So let's attach that to this other line. So we'll join. Okay, that's good. Now while we're doing this, let's see where the start point is. Let's go to the node editor. Okay, I want it to start here, so I'm going to right click over that, make start point. You notice it turns green. Now that's where the cutter is going to start. So what I've done at this point is I've created a straight line here that's going to actually be my toolpath. Okay, let's create that toolpath. It's going to be a profile cut. I'm going to use an 1.5 inch tool I've already defined. I'm going to cut about 200 inches a minute. I'm going to cut on the line. I just want to cut on the line. We're going to probably have it ramp in with a zigzag, and we'll make that ramp distance about 0.5. And we're going to call this fly cut. We're going to have it cut, by the way, about 10 thousandths deep. That's enough for you to see it. And let's hit calculate. So there's what our toolpath looks like. Now, let's simulate this and see what happens. Let's slow it down so we can see it, and we'll preview select. There you see it. You see how the cutter starts? Let's speed that up now. So it goes back and forth, and when it gets all the way across there, you have a surface that's fly cut. Now we're going to use this concept later where we actually started a certain thickness and ended a certain thickness, but this is the method that I typically use to do fly cutting. We're finally ready to start toolpathing our guitar body, and we're going to start with that bottom piece, and we're going to start on the back side. All right, the first thing we're actually going to do is fly cut it. Now let's think about this. The program that you see over here on the screen is very similar to what we just looked at, but a little bit more information. Now, when I actually went out and measured the thickness of the material, remember the bottom was smooth, the top is irregular. It looked to me like the thickest point was about 2 1/8 inches. So that's what I entered here as the thickness. Also note that we're touching off from the machine bed, which in our case is the top of the fixture board, and that will be the same throughout the rest of the project. Okay, so that looks good. Let's look at our toolpath. Let's open this up. Okay, one of the things that's interesting is where did that number come from? You know, Vcard Pro has some mathematic functions built in, so let's think about what we're trying to do. The finished bottom piece is 1.8 inches, but I don't want to really get there at this point because I'm going to turn it over and fly cut that again. So I think what I want to do after this operation is to be about 1 7/8 thick. So the easy way to do this is this. I'm going to take the material thickness, 2.125. I'm going to say minus 1.875 and hit the equal button, and it calculates it for me. So it tells me that I need to take off 1/4 inch. Now let's look over here in the tool definition, and you see that it's taking off 1/8 of an inch per pass, so it should automatically generate 2 passes. And we'll hit calculate, and there's our tool pass, and let's simulate those. There's the first pass, there's the second pass. So that's actually our first operation on the back side. Now let's go out to the machine and run this. Okay, now you can see the blank actually taped to the fixture board on the machine, just like we looked at earlier. You can see how rough it is. Notice the tool in the background. You can see that fly cutter that we talked about. Now let's look at the actual machining. Okay, you can see it's going back and forth. Wow, that's really nice. You can see the step over is about half the tool diameter, which it should be about 0.75. That really looks nice. And you see that takes a lot of material off. So this is a relatively quick process. Now let's check it out from a slightly different angle. You can see we're almost finished there. So it's a really, really nice process. And you see how smooth that blank is. That's coming out really, really well. Okay, we've got the backside fly cut and we're at our correct thickness. Now, what we want to do are the tool paths that we can't do any other way except from the back. And primarily that's going to be these pockets that you see on the screen. There's 2 pockets here. We're also going to cut outside of the perimeter about halfway through. And of course we have to machine the 2 holes for the pins. Now if you notice, if you remember back, those are opposite where they were on the fixture board because this has to be flipped. So this geometry has actually been mirrored. You have to make sure that you do that. And there's one other tool here, or drawing here, and that's actually a profile of a tool, and we'll come back to that. So first what we'll probably do is we'll probably do the pins. And there's basically just a tool pass for those. Let's just go to simulation. You can see what's going to happen here. So the first thing that's going to happen is we're going to actually do our pins. And the machine's going to come over and drill those 2 holes. Then we're going to machine those pockets. Okay, that looks good. Then we're going to machine the outside, but we're not going all the way through. And I want to show you something about that tool path, because if you notice here, I've got an allowance in here. Okay, and we're going to talk about in a second what that means. But basically, in short, what it means is the part's 30 thousandths oversized. And the reason I do that is because then what I do is I make the top oversized and the bottom oversized. Then in the final operation, I remove all that, and it gives me a real nice edge. So that's something you may not have thought of. Let's see what else we've got. Okay, then we've got some spot drills, and the spot drills are actually, you can barely see them, 1, 2, 3, and that's just to show me where some screws go later. And then finally is the round over. And by far, that's probably the hardest thing to set up. Now, before we actually output this and go cut on the machine, let's talk about how to create a form tool and make sure it aligns correctly in Vcard Pro. I want to take a little detour here and talk about form tools, because we're going to be using an 1/8 inch roundover bit on the back side, and the bit we're going to be using is actually a Vortex 3750. It's a really nice tool, and actually the tip of the tool is about 0.11, and then the overall diameter is 1/2. First I want to show you how you create a form tool in Vcard Pro, and it's really quite simple once you understand. First off, we start with a drawing that's half the profile, and we select it. Then we go to Toolpaths, Tool Database, New, and then from the drop down we select Form Tool, and you see it imports that drawing mirrored the other half. So it's telling me that overall it's a 1/2 inch in diameter. Depth per pass, let's just tell it 0.13, and we don't care about the feeds and speeds at this point. All right, so now we've created that tool. All right, let's apply that tool to some geometry. Now, if you look at our piece here, basically this is 12 by 12, and it's 3/4 thick. Okay, and so we're going to cut on the outside. We're going to cut 1/8 of an inch deep. Let's select that tool we just created. All right, and let's see what we get. We'll select our geometry, and we'll tell it calculate. And we'll simulate it, and it looks really good. Perfect. Yeah, that wasn't so much trouble, was it? Okay, well, let's go ahead and cut the outside out. So now I'm going to do another profile, and this time I'm going to cut all the way through, so 0.76. I'm going to use a straight tool, probably a 3/8 or something I've already got set up. Yep. Okay, and I'll select that geometry. We're cutting on the outside. We're going to do that, by the way, in one pass. And let's calculate and see what happens. All right, we're cutting through. That's normal. Okay, now we'll turn that off. Now let's run that toolpath. And guess what? What happened to our roundover? So now you see the problem with form tools. So let's dig back into this a little bit and see if we can figure out what's happening. Well, here's what the problem is. Let's open this up. It's just a little offset here. You see what happens is it thinks the tool's a 1/2 inch in diameter, so it moved the center out of the toolpath over 1/4 inch, so you didn't get any shape. So we have to use this allowance here, and basically a negative allowance moves the tool in, and a positive allowance moves it out. Okay, so what does that allowance need to be? Well, think about it. It's going to be the diameter of the tool minus the tip divided by 2. All right, so let's see if we can put that in a formula. Okay, so let's put a parenthesis. So it's 0.5 minus 0.11, and then we'll close parenthesis. So it'll solve that first, and then divide that by 2, and we hit equal, and there's our number. And it's 0.195, and since it's going in, it's going to be a negative. So it's really that simple. And then let's go back and recalculate it. And we'll preview it again. Looks pretty good. Now let's see what happens when we cut it out. There you go. And we'll double click that, and there it is. So that's how you use form tools. Now, there's one other thing we're actually going to be doing on here, and actually let's go back and reset that preview. Okay, what I'm really going to do is on this outside cut, I'm actually going to use an offset on it. I mentioned earlier that I want to cut it oversized, and that's where you do it, right at 0.03. So I'm going to have that offset 30 thousandths, and I'll trim that up at the end. Okay, we'll recalculate that. It's cutting through. Now let's simulate these again, and I think you'll be able to see it. So we'll simulate that, then we'll cut it out, and then we'll double click that and get rid of it. Now if you notice inside there, you see that little edge, that's at 30 thousandths. So that's how allowance works, and that's how form tools work, and I hope this helps you. Let's run our Toolpath simulation one final time to make sure everything is set up the way we wanted it to be. So we'll come over here and we'll say preview all toolpaths. That looks like our plan. Okay, now, so once we're happy with that, now it's time to output the G code, and let me show you how you do that. We're going to come over here and we're going to click the output button. Okay, now this brings this up. Now you notice this says output all visible toolpaths to one file. Make sure that's checked. Now this post-processor is for a non-tool changer machine. Even though we have a quick change spindle on here, we still treat it as a non-tool changer machine. So each tool is its own program. Now let's look at that a little further. Okay, when it says output all visible, that means they're clicked. So there's that. It shows you that toolpath. Now watch what happens when I click another toolpath with a different tool. I get an error message. So that pretty much keeps me from making a mistake. So I'm going to click that. I'm going to save toolpath. Now, I would recommend that you work at a naming system for your program so that when you're at the machine control, you obviously know what program is going to be used. Now, if you notice here, backside pins, I said number 1. That means this is the first toolpath you run. It's part of the backside setup. and it's pins, and it's a 1/4 inch bit. So just by reading the name of that program, I have a pretty good idea of what it's going to be, and that's how I do all these programs. So we save our programs. We do that for each one of these toolpaths. So that's going to be a program. These 2 toolpaths will be a program, and these 2 will be a program. So we've already done the fly cut. So out of this, we'll actually get 3 G-code programs. Let's go out to the machine now. Let's run these. Okay, we're actually going to machine the holes for the pins. Remember, those are used so that when we flip it and machine the other side, everything lines up. So we get that operation done. Then it requires a tool change. And then we'll actually switch over. This is an interesting bit. This is actually a Vortex 2310, and it's called a pass-by spiral upcut. And we'll look at it a little bit closer after a while, but it's got, it has the ability to cut really deep pockets without burning. So I use it for a lot of different operations. Now what we're doing on the back here is we're cutting these 2 shallow pockets. I believe in the finished instrument there's a plate that goes over those. You notice the step over on the cut. It's just a simple pocket cut. And then we have another pocket towards the back. I believe it's circular. Once again, all the stuff came off the 3D model. And finally, we're going to actually use that bit to cut the profile. Now, what we want to do is we want to cut a little bit deeper than half the blank thickness. And what we're trying to do is cut the outer profile of the instrument itself. Remember, we've still added 30 thousandths, so it's going to be a little bit big. Now, what will happen is we'll actually, when we do another operation, we will actually cut through from the top a little over halfway, and that'll free the blank up. Then we'll come back with a really smooth bit and do that outside edge and remove that 30 thousandths. Now finally we're going to take our roundover bit, and what I'm really doing in this operation is just marking some centers. The tip of that bit's 0.11, so it makes a lot of sense to just use it as a marker rather than load another drill. Once again, those are going to be the centers for some screw holes. And then finally we'll take that bit and we'll go all the way around the perimeter and we'll create that 1/8 inch roundover. And if you look really close, you can see our 30 thousandths offset that we left on the outside cut. This comes on around. That makes a really nice cut on that edge. Let's take a minute and talk about the bit that we just used on the back side. It's a Vortex 2310, and it's called a pass-by spiral upcut. And I use it for a lot of different operations where there's really deep pockets. Now here's why. If you look real closely, you'll see that this bit happens to be 3/8 in diameter, but there's a cutting edge about 1 inch tall. And then the bit gets smaller above there, so you can really cut way down deep in pockets, and you don't get the burning that you get on standard bits when you try to cut that deep. The machining operations for the back side have been completed. Now all we have to do is remove the blank, turn it upside down, position it on the pins in the fixture board, and that's what makes the front and back line up. Then we're ready to actually apply the toolpaths for the top side of that blank. Let's look at those toolpaths. What you see on the screen is the geometry that we're going to need to toolpath the top surface of that lower blank that's part of the guitar. Primarily it's areas that we can't really access any other way, so we're going to make a through cut here, a through cut here. This is a groove to a certain depth. We're going to pocket this out to remove weight in the guitar body. But there's one step we need to do first, and that's to fly cut it to the finished thickness, and that thickness is 1.8. And right now our material is at 1.875. So all we do is open up our fly cut program, and once again, I let Vcard Pro calculate this for me. 1.875 minus 1.8, and then equal. That calculates it for me. And I'll need to turn the geometry on so that we can see it. We're going to toolpath just like before. And then all we have to do is hit calculate. And let's make sure that's reset, and let's preview it. And there's our toolpath. So now let's go out to the machine and let's actually do that fly cut now. I'm really impressed with how well the ShopSabre 23 did this fly cut operation. That's an 1.5-inch cutter at 200 inches a minute, and that's an HSK tool holder that's part of the quick change spindle setup. So it really, really did a nice job. Now let's go back to our drawing and let's finish the toolpaths we need for this setup. Okay, the first thing I think I'll do is check and make sure that I've got the thickness allowed for. Okay, there's my thickness, 1.8. That represents our final fly cut. All right, so we're good there. Then let's look at the toolpaths. Here's the first one. First toolpath is going to pocket these out. Then we're going to cut that slot. And then we're going to do that cutout. Let's look at that in simulation. So the first thing that's going to happen is we're going to cut the through pockets. You can see those. And then the slot. And then the cutout. And the beauty of this is those were all done with the same tool. They were done with that deep tool that we looked at. So when I get ready to output it, all I have to do is select all of them, save toolpath, we're going to name it, and we're going to save it. And that's all there is to it. Now, once this is done, then we glue the cap on to do the final setup. Let's go out to the machine and let's run these toolpaths. So you see, we just basically do a pocket operation. It steps down so much per pass, and eventually it gets all the way through. And we've sped that up a little bit now. We're towards the end. That retracts, then it moves to the next position. Once again, this is another pocket. Those are actually the same tool path because both cuts are the same depth. That's kind of what determines that. Now this is a larger pocket. Once again, this is going to go all the way through just like the earlier one did. Now we see it's cutting a little bit deeper. And finally, it cuts all the way through. Now we move over and we start the slot. And then finally, this is the cutout. This is the largest pocket. Remember, in this operation, what we're doing is removing mass from the block so that the guitar body doesn't weigh so much when we're finished. Once again, it's a pocketing operation. And finally, we're just about finished. Wow, that looks good. Well, our machining came out really nice. The pocket's all machined cleanly. Everything looks really good. It looks exactly like it did on our simulation. We've completed all the machining on the lower portion of our Les Paul guitar body. Now we remove that from the machine and we glue a maple cap on top. Alright, the maple cap itself has been fly cut so we get a good glue surface. Then that gets reintroduced back to the machine. We use part locator pins for alignment and double stick tape to hold it in place. And once again, our first process then is to fly cut it to a specific thickness. In our case, it's 2.55 inches. Let's take a look at the fly cut simulation in Vcard Pro. There's the first pass, second pass, third pass. Now let's go out to the machine and fly cut our blank. Now we're ready to create the 3D surface for the top of our guitar body. Let me show you how you do that in Vcard Pro. First off, I've opened up a drawing and I have all the geometry that I'm going to need later to do the top cap pocketing and all that stuff. And it has the outline. Now let's check our material setup. And our material thickness is 255, which should be where it's at after we fly cut earlier. So that's good. Now I'm actually going to need a 3D surface, and let me show you how you bring that into Vcard Pro. You go to the modeling tab at the bottom. Okay, click on this button and that lets you open a model up, and there's my component. Alright, now when you open that 3D model, it brings this up. So now what you have to do next is figure out how to locate it. So the easiest thing to do is, number one, tell it to center the model. Okay, that looks pretty good. Then you have to worry about where the zero plane is. And so what I usually do is bring that and also tell it to discard any data below that. So we've positioned the model into the software, and that brings it in. And when I click this, you can see it. So there's our 3D model. All right, so now we've brought that into the software. Now, there's another step that's required, and that is, where is it positioned in the block? Well, first off, is it centered? Now, it appears that it is. If it wasn't centered, here's what you do. Let's say that came in and it wasn't centered. Maybe I made a mistake. Well, here's what you do. You click this, you hold the Shift key down and click that outline. Go over here to the Drawing tab and click that, and that centers that automatically. You know, the next thing I need to know is how thick is the 3D model. I went back to the bounding box and I looked for the height in Z, and the total model is 2.468 inches tall. Okay, now let's see how that relates to what we're doing here. First off, let's go to the tab over here that says Toolpaths, and we'll pin it, and then we'll hit Set. Now what this actually shows you is where the model is in space. Right, so what we have to do is we have to figure that out. All right, well, let's figure out what is the gap above. Well, let's do it mathematically. So we start with 2.55, and then we subtract 2.468, and hit equal, and it calculates it for me. So now that automatically positions that surface at the correct height. And we hit OK. Alright, and we've got some toolpaths already in place here, and we'll look at those. The first thing you do is pretty much you do a roughing toolpath. We'll open that up. When we do a roughing pass, we're pretty much going to use a ball nose tool. In our case, we're using a 3/8 ball nose. Okay, let's open that up. Alright, now one of the things that's neat about this is how you select the geometry. When you're doing a 3D model, you know, there's different ways. I can do the material boundary. Basically, what I want to actually do is this boundary of the model itself, so I'm going to say that. All right, I've added a machining allowance. It's a rough pass, so I don't want to bring it all the way down to the finished surface. And let's hit Calculate. And that creates our first roughing 3D toolpath. And if we run simulation, you can see it goes back and forth. The step over is about 50%. The whole purpose of this is to just remove a lot of material fast. Okay, once that's done, then we go to Finish toolpath. Once again, the same model boundary. Primarily the difference is we're doing a step over of about 8%. That's what really gives you the nice finish. And we'll hit Calculate. And that gives us our finishing toolpath. And when we run that, that produces our really, really nice smooth surface. Now let's go out to the machine and let's cut these surfaces. Now that we have our 3D surface cut and our Les Paul guitar body, now we're ready to do the remaining toolpaths that actually complete this exciting project. Let's take a look at Vcard Pro. Now let's take a look at this geometry that we're going to use to complete these operations. There's a pocket for the neck, there's some pockets for pickups, and then these are actually holes that get machined to access cavities underneath. And of course here's a perimeter. Now let's look at the simulation at this point and let's see what's going to happen. Okay, the first thing that's going to happen is we're going to do a pocket, and that's once again for the pickups, and here's some adjacent ones, those get cut. Okay, then we also have some pockets for holes, and those are actually access into cavities underneath. There's probably for switches. Then we have a toolpath that's a rough toolpath for the neck. Once again, that's removing a lot of material, but remember the neck has a 3D surface underneath there, and so that's what this neck finishing pass does. And then we cut the outside, and that's actually going to cut all the way through, because remember we've cut halfway through on the other side, and this will be our finished toolpath, and that cuts it out. And when we get finished, we have our guitar body. Now let's take a slight deviation at this point, and let's take a look at that 3D surface in the neck. All right, this is what that 3D surface actually looks like, and here's why it's constructed this way. For one thing, there's a flat plane here, and that's put on there because that gives you alignment automatically, because that flat plane represents the size of the blank. And then this is the actual surface above, right on top of here. So what happens is when we actually toolpath this, the toolpath goes straight down to that surface. In fact, let's take a look at that. Let's go to simulation again, and let's look at this. Let's rough our neck out. And you see then there's this finished toolpath. Let's take a look at that. Now what happens when you open that up, what happens is you see the cut depth. This is clicked down here that says project toolpath onto 3D model. So basically if you put 0 in cut depth, the surface is going to be the actual plane. So you can adjust that surface up or down. Alright, this looks great. Let's preview all the toolpaths. Now let's generate our programs, and let's go out to the machine and let's finish up this exciting project. Okay, we start out with the neck pocket, and that's that pass-by tool that we used earlier because it cuts so deeply. Now these pockets actually go down into the bottom part of the blank, into the mahogany, but we'll actually cut that as part of this operation. Then we don't have to worry about it lining up. Once again, a typical pocket, and you can see now we're cutting down into the mahogany itself. You can see why you need that deep tool. And of course that actually has that 3D surface at the bottom of that pocket. Now the next thing we're doing is we're actually machining holes, and I'm actually cutting those with a router bit as a spiral inside cut. Once again, those actually line up with some pockets underneath. Then we start cutting the pockets. These are actually for the pickups, I believe. And here's the second pickup. Once again, a typical pocket operation. Then there's some other small pockets, and once again I believe those are for hardware. And this should finish up those pockets. Now we're actually using that tool to cut the outline. Remember, on the underside we cut it about halfway through. Now we're going to go around the body, and we're going to cut a little past the halfway point. So this cut is actually going to separate the skeleton frame in the corners from the guitar body itself. Remember that we're still 30 thousandths oversized. Our whole idea was to give us some room for trimming just in case our pins weren't perfect. And this should be the cut that actually cuts through to the underside. Now you simply pry that up, that outer skeleton comes out, and what you have left is your guitar body. Now we're going to do one of my favorite operations. What we've done is we've taken a really nice 3-flute finisher. It happens to be a Vortex 1865. The bits has a cutting edge of 2 1/8 inches. So I can actually go around that entire body, remove it in one pass, and that gets my guitar body down to the actual final shape. And once you do that, you see the little pocket on the setup board? That's all there is to it. Well, I hope you enjoyed this ShopSabre Make It series video. Our Les Paul guitar project came out really, really nice, and the edge finishes are good, the fit's perfect, and there's a lot of neat operations in it. And remember, if you're part of the SabreNation community, you have access to the files we used in the video. If you need those files or you have any questions about this project, you can contact us at shopsabre.com. Thank you for watching.